Now that we've discussed all of the trigonometric functions, let's talk about some of the properties that they have. So what I have drawn here is my xy plane, and I have two angles drawn. I have one which is some positive t angle, so positive t, and then I have the negative version of that drawn as well, negative t. Now I also have, of course, my unit circle drawn, and so maybe I should mark down that this is in fact the unit circle by indicating that the intersection with the x and y axes happen at x equals 1 and y equals 1. And let's take a look at this terminal point, and let's call the terminal point for t x comma y, as usual. Well, if the terminal point for t is x comma y, then what is the terminal point for minus t? Well, if you draw a vertical line, you'll see that these have the same x-coordinate. So the x-coordinate of this terminal point down here is going to be the same as the x-coordinate for the terminal point up here, so x. And now how about the y-coordinate? Well, the y-coordinate is kind of the same, except instead of traveling upwards, you have to travel the same amount downwards. So this is going to be minus y. And now remember that cosine of an angle, cosine of t, that is the x-coordinate, this coordinate right there, double underlined, and that x-coordinate is the same as this x-coordinate. And this triple underlined x-coordinate, that is the cosine of negative t, because it is the x-coordinate of this particular angle minus t. So there's two things going on here, and perhaps I should write this in a couple different steps. The first is that cosine of t is x, and also cosine of minus t is equal to x. So cosine of t and cosine of minus t are equal to the same thing, so that means cosine of t is going to be the same as cosine of minus t. Let's take a look at what happens for sine. So sine of t, that's equal to y. That information we get just by looking at the y-coordinate for this t value. But what is sine of minus t? Let's take a look. So sine of minus t, well, that's not equal to y. It is the negative of y. And unlike cosine of t, sine of t and sine of minus t are not equal to one another. One's equal to y, the other one's equal to minus y. However, you could take this first equation and multiply both sides by a negative, and we get two things that actually are equal to one another. That is negative sine of t, that's equal to minus y, and sine of minus t, that's also equal to minus y. And so the result here is that sine of minus t is negative sine of t. And so there's two important results that we have so far that's worth making their own line. The first is that cosine of minus t equals cosine of t for all t, and sine of minus t is negative sine of t for all t. Now similarly, you can find that tangent of minus t is negative tan t. It's not too challenging. You actually do the exact same steps. So tangent of t, that's y over x. That's just looking at my picture over here. So making this a little bit cleaner, there we go. So tangent of t, that's y over x. And what's tangent of minus t? Well, that's the y coordinate here, which is negative y over x. So, and tangent of minus t is negative y over x. And so if you multiply the first equation by a negative, then we see that negative tangent of t and tangent of negative t are equal to the same thing. And so tangent of minus t is equal to negative tangent of t. Finally, I'll finish up this conversation by noting that cotan of minus t is in fact negative cotan of t, not cosine, but cotan of t. And cosecant of minus t is equal to negative cosecant of t. And secant of t behaves the same way that cosine does. So I think I'll put it up here. Secant of minus t is the same not as negative secant, but just secant of t. And this is true. All these statements are true for all t. So you could put for all t after all of these statements. Now, earlier in the course, we learned about functions with what we called various symmetries. That is, if a function was symmetric about the y-axis, we called it even. And if a function was symmetric about the origin, we called it odd. Algebraically, if you have f of minus t equals f of t for any function for all t, we say f of t is even. Now, via transformations, the left-hand side represents a reflection about the y-axis, and the right-hand side represents the original function. So this is saying right here that the reflection about the y-axis is the same as the original function, which is how even and odd functions are typically introduced. So secant of minus t is secant of t, and cosine of minus t is cosine of t. So in other words, these are even functions. We'll see later that their graphs are symmetric about the y-axis. Now, we also had previously learned about odd functions in which they were symmetric about the origin, which means if you reflected them twice, you got the same function. That is, if you take a function, f, and you reflect it about the y-axis and the x-axis, then you get the original function. So if this is true, negative f of minus t equals f of t, or what's also written very frequently is you multiply both sides by a negative and you end up seeing that f of minus t is negative f of t. Then we say, and this has to be true for all t, I should say. So for all t, then f of t is odd. And so the result here is that these functions are all odd. And when we examine their graphs, we'll see that if you reflect these functions about the x and y axis, you get the same graph. Practically speaking, you can determine if you know what sine of t is. So let's say, suppose sine of t, and I'm using sine of t as an example, but you can use any of the trigonometric functions as an example. But if you know sine of t is equal to, let's say, 3/4, then you can determine what sine of minus t is without even knowing what t is, because sine of minus t is negative sine of t, and we know that sine of t is 3/4, so this would be 3/4, or excuse me, negative 3/4. And as another mini example here, if you know, let's suppose that cosine of t equals, I don't know, let's say -1/8, then cosine of minus t, so going back and looking at this, says cosine of minus t is the same thing as cosine of t. So it says right there. So that means that cosine of minus t, that's the same as cosine t, which is -1/8.